Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a hyperbolic function, and with that in mind, let's get straight into it. They've said to us, the sketch below shows the graph of f of x equals minus 9 over x minus 1 minus 2. A is the point of intersection of the asymptotes of f. The very first thing they've asked us to do is to write down the coordinates of A. Okay, so what's special about A? Well, they've said to us that the A represents the intersection where the two asymptotes meet. So what are the asymptotes of this? Let's have a look at our formula. The formula gives us exactly what our asymptotes are. So let's write down 5.1.1. Okay, and we're trying to find the coordinates of A. So what is the x coordinate? Okay, so we know it's going to be something positive. It's to the right. How do we use this in order to solve it? Well, we can see that we've got a p-value of minus 1. So we know that needs to be the minus p-value. So your asymptote, your x asymptote, is going to be minus p. So minus 1 is going to be 1. And that sort of looks like the right spot for point A. Then if we look at the y-axis, the y point of this coordinate, we can see that A is negative. It's on the negative side, so it's below the x-axis. So we're looking at some sort of negative point here. And if we look at our curve, if we look at the equation of our curve, we've got a minus 2. So that minus 2 is our q value, and we know that the asymptote, the y asymptote, is always going to be that value, exactly that value. So it's going to be minus 2. And that is, in a nutshell, point A, which is the intersection of the two asymptotes. Moving on to 5.1.2, determine the coordinates of the x and y intercepts of f. Okay, so that's always a common question that you'll get, and you've been getting these types of questions since grade 7 or 8, so it's really useful to get some good marks here. So in order to get our x-intercept, so let's look at our x-intercept first. What do? We need to let y equal 0. Okay, what is y in this sense? Well, we know f of x is the y. So y equals f of x. So we're going to say that 0 equals minus 9 over x minus 1 minus 2. And now we need to solve for that x value. So because it's in the denominator, we need to multiply. We need to try and get rid of this denominator, and therefore we need to multiply all of the terms in this equation by that denominator. So the 0 times anything is always going to be 0. Then we know that's going to stay minus 9. And then we're going to have minus 2 brackets x minus 1. The brackets are so important because it means we need to use some distributive law. So it's going to be minus 2x plus 2. Right, so now we've got minus 9 plus 2. That's going to give us minus 7. We're going to take that to that side, the minus 7, which will become a positive 7. And then we've got minus 2x left. Okay. Once we are there, we can now divide both sides by minus 2. And that is going to give us an answer for the x-intercept of minus 7 over 2. We can't simplify any further. So it's minus 7 over 2 equals x. And to write it out as a coordinate, we're going to say the coordinate then, therefore, is minus 7 over 2, 0. Okay, so that gives us the x-coordinate, or the x-intercept of this curve, which is great, and that gets us a few marks. I'm going to do the y-intercept just below. Right, so I'm going to do the y-intercept now. So what do we do when we look at the y-intercept? We do the very opposite. We say x is equal to 0, and using our curve, we're going to say y is equal to minus 9 over, okay, so it's 0 minus 1, so it's minus 1 minus 2, and that's going to give us now 9 minus 2, so therefore y is simply 7. Okay, and that would mean that the y-intercept in this instance is going to be 0 and 7. Okay, so I'm going to write that in on my graph just so I don't forget. So I'm going to put a minus 7 over 2, okay, which indicates my x-intercept, and I'm going to put a 7, which indicates the y-intercept. And what I'm going to do is I'm going to clear this out just to give myself a little bit of space for the next question. Remember, you can pause the video, go back, rewind, fast forward through this erasure. Right, okay, that gives me a little bit of space. Now they've said to us, write down an equation of the axis of symmetry of f that has a negative gradient. Okay, so this one always is a little bit tricky, only if you don't know what to do. Now remember, our negative axis of symmetry is going to simply be y equals minus x, okay? And we need to try and figure out what that c value is. So in order to figure out what that c value is, we need to plug in a point of y and x that is on that axis of symmetry. And we know that A is clearly a point on that axis of symmetry because it cuts through, right, the two asymptotes. So the two asymptotes, where they connect, that is also going to be a point on which the axis of symmetry lies as well. Right, so we can plug in that point. Remember, we did it in 5.1.2, and that point was A, remember, and it was 1 minus 2. So we're going to sub that point in, which is going to give us y is equal to the x here, we're looking at minus 1, okay, plus c, and we can plug in that y as well. So that y is going to be minus 2, so we're going to bring that minus 1 across. That's going to be a positive 1, so we're going to have minus 1 equals c, and that is the answer for c. So therefore, the axis of symmetry here is going to be y is equal to minus x minus 1, and that will get you the answer for that question. Moving on to 5.1.4, hence is always an important word. Whenever they use the word hence, it means look at the question directly above, and that will give you some guidance. Determine the coordinates of a point that lies on F in the fourth quadrant, which is the closest point to A. Okay, so they've said to us, write down the coordinates of a point that lies on F in the fourth quadrant. So this is our fourth quadrant over here, which is closest to point A. Okay, so they're trying to find a point over here that is closest to A. And we know that that point must lie on the axis of symmetry line that we just calculated, because that's going to be, at a diagonal point of view, the closest point to point A. So that means that we can generate our own equation now. Okay, so that's quite important. So we're going to say, right, the line minus x minus 1. What do we know about the line minus x minus 1? Well, we know that that is going to give us a y value. Okay, so that's going to give us a y value. And that must equal the point on y at which minus n over x minus 1 minus 2. So can you see in order to solve this, because we know that the closest point to A is going to lie on our axis of symmetry that we've just calculated. So in order to do that, we're going to try and find the intersection of the two lines. So that is why we've equated the two y's at that point, which is going to be this point over here. So those two y's must equal each other. Now we can calculate what the x could be in that situation. Right, so let's now solve for our x. What we're going to do first is we're going to multiply every term by the x minus 1 in order to get rid of this denominator. And that's going to give us minus x, and that's going to multiply x minus 1. Then we've got minus x minus 1 equals minus 9 minus 2, and that's going to give us times x minus 1. All right? So now we've got a little bit of work to do in terms of getting rid of those brackets. So we're going to start with that. Minus x squared plus x minus x plus 1 equals minus 9 minus 2x plus 2. Now we're going to solve all of these x's and numbers and x squareds. So we've got 1x squared that we're going to keep, and that's going to be minus x squared over there. Then these two x's can cancel out. We've got a minus 2 that we can bring across. That's going to be plus 2x. And then we've got a 1 over here, and we've got a minus 9, and we've got a plus 2 over there. So once we bring all of those across, we're going to have plus 1, plus 9 gives us 10, and then minus the 2 gives us 8. So that's going to be plus 8 equals 0. So now we can see that we've got some sort of quadratic equation coming through. What that means is we expect that there are going to be two answers. What I'm going to do is I'm going to clear out this space just to give myself a little bit more room, and I'm going to continue the question over there. What I don't like here is this negative, so what I'm going to do is I'm going to multiply everything in this equation by minus 1. If I do it to everything, nothing changes. Remember that. So it's going to be x squared the minus 2x minus 8 equals 0. So now let's try and solve for x using our trinomial factorization. So we're going to open up our two brackets, right? We're going to look at this sign over there. We know that means that we need to have two different signs in our brackets. Because there isn't a coefficient here, we know we'll have an x here and an x here. And then we need to look at two numbers that multiply to 8 and subtract to 2. So that is going to be 4 and 2. And we know that the 4, the bigger number, must go to where the negative sign is. So that's going to be 4 and 2. So therefore, x is either minus 2 or x is equal to 4. Now, why do you think we've got two answers for x here? Right? Well, the reason being is we're going to have 2 points that cut across our axis of symmetry. So we can see that there's going to be a point over here and there's going to be a point over here. But very specifically, they've said to us in the fourth quadrant. Okay? So we know in the fourth quadrant, our x is going to be positive. So therefore, this one does not apply. So it can only be x equals 4. Once we have done that, we can solve for our y value, because remember, they've said to us, determine the coordinates. So we can't just give them an x, we need to give them the y as well. So therefore, we're going to use the simpler one. So we're going to use our minus x minus 1. So that's going to be y is equal to minus x minus 1. We plug the 4 into the x's spot. That's going to be minus 4 minus 1. So therefore, at that point, our y is minus 5. So therefore, the coordinates that they are looking for is going to be 4 and minus 5. And that is a lot of hard work for some really well-deserved marks. So really good job for getting that far. Remember, you can rewind, rewatch this again and again until you really understand what's happening. I'm going to clear out again, just to give myself a little bit more space. All right. Feel free to fast forward through this point. Right. Okay, so let's move on to our very last one now. So the last question states, the graph of f is reflected about the x-axis to obtain the graph of g. Write down the equation of g in the form y equals. Okay. So the graph of f is reflected about the x-axis. What does that mean? So we're going to be reflecting it across this line. So we're going to reflect it, and essentially that's the new curve that we're going to expect. What do we notice about the new curve? Well, we notice that all of our x's stay the same, but our y's become negative. Okay, so what does that mean? It means that in order for us to translate from f of x, we need to move to minus f of x. And that means that all of our y values become negative. So the way we can do that is we say, therefore, minus y is equal to minus 9 over x minus 1 minus 2, right? And now we need to get rid of this negative sign. So what's going to happen is we're going to times everything by a minus 1, and that's going to be y is equal to 9 over x minus 1 plus 2. And if we look at what we expect that curve to look like, we can see that we're expecting, okay, we're expecting there to be a positive, okay, y-intercept. We're also expecting there to be a positive type hyperbola, which is the shape that we're expecting to get. So that must be the reflection of that curve in the line x equals 0, or across the, it's not x equals 0, y equals 0, across the x-axis. So really important, really good job. These were a couple of hard questions, really testing your understanding of hyperbolas. Make sure to rewatch, rewind, share with friends that you know are struggling with this hyperbola. And while you do all of that, keep in mind that because of our epic sponsors, that is the reason this video is made possible. Thank you so much to them. Read all about them in the description below. Remember to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.